For letter J, we've got our concentration of, what's this called? This is a sulfate, SO4, sulfate. It's got some hydrogens tacked onto it, so it's an acid. 8 changes to ic. This is sulfuric acid. It's a strong acid. Our concentration is 0.00349. Because it's a strong acid, we can say that that concentration is the same as our concentration for hydrogen. Or can we? Can we say that? We can't. Why can't we? Because we've got 2 hydrogens. So for each molecule of hydrogen sulfate that goes into the water, we clip off these hydrogens right here. And so we get 2 hydrogens freed from our hydrogen sulfate. So our hydrogen ion concentration is going to be 2 times 0.00349. To figure that out, let's just calculate that. And when we calculate that, we get 0.00698 molar. Again, because we get 2 hydrogens coming off of every molecule of hydrogen sulfate, we double the amount of hydrogen compared to the concentration of our sulfuric acid. So now we've got to figure out pH. Well, we've got our hydrogen ion concentration here. It's pretty easy to do. pH equals negative log of this stuff right here. Negative log 0.00698. And to figure that out, run it through a calculator, and we get a pH value of right about 2.16. It's 2.15614 and change. So that will round out to 2.16. Letter K is pretty straightforward. We have our pH of 2.05, and we want to know our hydrogen ion concentration. To get to our hydrogen ion concentration from our pH, all we have to do is antilog the negative pH. Antilog negative 2.05. Run that through the calculator, and we get right about 8.9. Get that point a bit better. 8.9 times 10 to the minus 3rd molar. Just like that. These should be getting fairly easy by now, I hope. And for our last problem in this sheet, I'm going to just draw a little battle map here. Our pH is what we've been given, and we want to know our hydroxide ion concentration. So it's really simple how we get there. pH, we need to get to our pOH, and then from our pOH, we'll get to our hydroxide ion concentration. You need to know how to get through those steps, though, of course. Our pH is 4.94, so what's our pOH? We go back to our trusty, 14 equals our pH, which is 4.94, plus our pOH. Do the subtraction, 14 minus 4.94, we get a pOH of 9.06. Okay, great. So we've got our pOH. Now we need to change it into our OH concentration. To do that, we look at our formula that works for us. Our OH concentration is equal to the antilog of our what? Our negative pOH. So the antilog of a negative 9.06, and that would equal about 8.7 times 10 to the minus 10th molar. There you go. That is all the problems on this sheet. They're pretty easy to fairly complex, depending on how you look at them. Make sure you know how to do this. This will be on the test on Monday and will be on the final. You need to know, if I'm given one thing, how do you get to the thing that you're asked for, even if it's 2 or 3 or 4 steps away. You need to be able to clearly see your plan.